Okay, so keeping in mind that the principal energy level is the period number, and that the location of the group we're talking about kind of dictates the shape of the orbital. So in groups 1 and 2, the block there on the periodic table is called the SBlock. That's because it forms a little sphere. So in period 1, groups 1 and 2, we have only the 1s energy level and shape. If we go down to the next period, we have the 2s. So the 1s is still in the middle of this. It's the little pink dot there, right here. But interestingly, there's like a shell of another sphere around there. In between the 1s and the 2s energy levels, which stack on top of each other, is a white region here, which electrons are not allowed to go in. So in this white space, electrons are not allowed to go there. So the green and the orange space represent the tops of the stairs where we said electrons can be. But the orange part represents the in-between spaces. Electrons are not allowed to go there. So this matches Bohr's model so far. They're just sort of spheres around the nucleus of the atom. At the n equals 3 energy level, we add another layer to the onion, and there's another gap in between. So now you see there's 2 white rings where electrons are not allowed to go. Now, once we get to the second energy level, and that would be period 2, there is another shape that can form, another shape the electrons might take on, and it looks like 3 bow ties together. So you could draw this by sort of making like a figure 8 to show the green one, the vertical one, and then another figure 8 to show the yellow one, and then a third figure 8 that shows the red one. It kind of comes off at an angle. So each one of these represents a shape, an orbital. Right? So here's our yellow. Super awesome coloring skills here. Our green is one shape. So even though the lobes, the 2 pieces, are on opposite sides of the atom, they still count as the same orbit, the same orbital. Okay? So you need to remember what these shapes look like for the s and p orbitals. S is pretty easy, it's just spheres. But for the p orbitals, it's a little bit tougher. Practice drawing this and like thinking about what it looks like. Okay, on the third period, there is still s orbitals and there's p orbitals. But then a new player comes into the game. We have something called d orbitals there, which are a crazy collection of shapes. Now, the s orbital has just 1 shape. The p orbital had 3. And as we keep going on, we add another 2 shapes to it. So the d orbitals have 5. When we go down one more period into period 4, there's something called the f orbitals, which there are 7 different shapes. I don't expect you to remember the shapes for the d and the f orbitals, but I do expect you to remember that there are 5 d orbitals and 7 f orbitals. There are always spaces in between each shape where electrons are not allowed to go. We call that a node. Okay? As we increase each energy level and each shape actually exists in the same space at the same time, they kind of overlap each other. As we go up in, say, the S shape, the first one is just a little sphere, and then you get an outside sphere like that, and then you get another layer, and another layer, and it keeps building on itself. So the lowest energy atom is at the top of the periodic table, and the highest energy atom is at the bottom, because we keep adding layers as we go down the periods. Okay, so these are the d orbitals I mentioned to you. There are 5 different ones. They all have different shapes, and they're oriented in space a little bit differently, but those together create the d sublevel. That just means that they all have they exist on one of these shapes. If we look at just one of them, if we look at the dxz shape, and we draw it for n equals 3 and n equals 4 and then n equals 5, something interesting emerges. we have these same layers in the d orbitals that we had in the s's and even the p's. I didn't draw it, but they're there. So you can see that there's spaces. Let me make this a lighter color so you can see it better. There's spaces in between all of these layers where the electrons are not allowed to go. So those are the things that we called nodes. And so all shapes have nodes. You can see that there's no electrons allowed in this spot. That's a node. There's no electrons over here. That's a node, like that.